Hey guys, today we're going to talk about 3.8, graphing tangent and cotangent. So we're going to use a lot of the same skills from graphing sine and cosine. Okay, there's just going to be a couple of vocabulary changes and a few formulas. Okay, so one thing to notice about tangent and cotangent is that they're really fractions. And so when the denominator of a fraction equals 0, the function is going to be undefined. Okay, so tangent is going to be undefined at multiples of pi over 2, and cotangent will be undefined at multiples of pi. So that's the first thing we want to know. So in the graph, these are going to show up as asymptotes, these values. So we don't say amplitude or phase shift for tangent and cotangent. Instead, we use a vertical stretch or shrink and a horizontal shift, because the shape of tangent and cotangent are not sinusoidal, funny word, okay, but sine and cosine, these shapes are called sinusoidal, and tangent and cotangent have shapes that don't look like that. Okay, and the last thing that we want to note is the period for the parent functions is now pi, rather than sine and cosine being 2 pi. So our basic form of the equations, A, B, and C are in the exact same location as sine and cosine. Okay, your vertical stretch or shrink, which was once the amplitude, is still absolute value of A. Okay, period, same idea but different numbers. It's now pi over B. Horizontal shift and vertical shift formulas remain the same. Now, what table of values will we be using, for each of these parent functions? So tangent, we actually start at negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. Now we just said that tangent is undefined at multiples of pi over 2. Okay, so the first and last y values are going to be undefined, and then these middle ones are negative 1, 0, and 1. Okay, so what does this look like on a graph? I'm going to space this out a little bit. Alright, so we said that any of those undefined values were going to show up as asymptotes in the graph. Okay, and then we have 3 points that we're plotting. So we'll make this -1, +1. Change our color here so it's a little bit easier to see. Alright, so negative pi over 4, comma negative 1, 0, 0, and then +1. So it looks very similar to kind of a cubic function. Okay, it's got that slight curve in the middle, and then it approaches the asymptotes on either side. So this is a tangent graph. Cotangent, unlike sine and cosine, has its own table of values that's different from tangent. So cotangent is actually going to go 0, pi over 4, pi over 2, 3 pi over 4, pi. Now you'll notice in both of them, we did one full period, because the period here for a parent function is pi. Well, from negative pi over 2 to positive pi over 2, That's a distance of 1 pi. And from 0 to pi, again, a distance of 1 pi. So we're getting in one full period here so that we're seeing the entire shape of the graph. Now, cotangent is undefined at multiples of pi. So 0 is actually undefined, and pi. Okay, and then these values in the middle are going to be reverse from tangent. So that's one thing that they have similar to each other, even if the x or theta values are different. Okay, so I'm going to change my color here. On 0, on 0 and pi, we have those vertical asymptotes again. Okay, make this +1, -1. All right, so okay, same. Whoops. Could make that a little bit better, I think. There we go, that's much better. So same idea as tangent, but since those middle values were reversed, the direction of our graph is going to be reversed. All right, now let's apply some transformations. So my vertical stretch or shrink, this is my a value, so this is 2. Period will be pi over b. So pi over 1/2 is 2 pi. My horizontal shift is c over b. Remember, c value is the opposite sign. Okay, so this is a plus pi over 2. And my vertical shift is up 1. Okay, so we're going to apply all of that to our table of values. Okay, so tangent, negative pi over 2, negative pi over 4, all the way up to pi over 2. Okay, so first and last are undefined. Now, if those values are undefined, you cannot multiply by the a value and you cannot add the d value. So they are undefined all the way through on the right side of the table. Okay, we have actual y values for the other ones. Therefore, we can multiply by 2 and add 1. Okay, and then the other side. So this, remember, is theta divided by b. Okay, so we take our x values and we divide them. Now, the x values are not undefined. So we're going to need to know, well, where are we moving those asymptotes to? Okay, so theta divided by b value, which is 1/2. So we're really doing 2 times theta. Okay, so negative pi over 2. Okay, we're really multiplying by 2. Gets us negative pi. Negative pi over 4 times 2. negative pi over 2. Okay, and those are just going to be the positives of that. All right, and then C over B, pi over 4. Oh, wait, we did this. Duh. Let's go back for a second. What did we get? We got positive pi over 2. All right, so we're going to add pi over 2 to each one. Okay, and we can now set up our graph. So I think I have enough spaces here that I can count by 2s. Alright, so negative pi over 2 is undefined, so an asymptote. 3 pi over 2 is undefined, so an asymptote. 0, comma, negative 1, pi over 2, 1, and 2 pi over 2 is 3. Okay, you want to make sure not to just get a straight line here, but have, that little bit of a curve in the center there, really coming into the asymptotes. All right, let's take a look at cotangent. So there's no number in the front here, so that means that my vertical stretch or shrink is 1, which really is having no effect on my graph. My period is pi over 3. My horizontal shift is pi, and the vertical shift is down 2. Okay, so let's create the table. Okay, remember these have different x values. Okay, first and last, always undefined, and carry that through. And we go 1, 0, negative 1. Okay, so the A value is 1, which means that nothing changes. And then D, we are subtracting 2. Okay. Theta divided by B is going to be theta divided by 3, okay, or theta times 1/3 if we have a fraction. So I get a 0, pi over 12, pi over 6, pi over 4, and pi over 3. Okay, now it might be a good idea to make a common denominator out of all of those, okay, so that I can have a nice consistent scale when I graph. Okay, so 0 and pi over 12 I'm going to keep. 12 looks like it's going to be the common denominator. So then 2 pi over 12, 3 pi over 12, 4 pi over 12. Okay. We found that our phase shift was plus pi. Okay, 12 pi over 12 is the same thing. Okay, so I was just taking all of these common denominator values from down here and adding 12 pi over 12. Okay, so we want to have a consistent scale so that when we graph, I could do like a little break here and start at 12 pi over 12. All right, so 12 pi over 12 is undefined, and 16 pi over 12. Oops. Okay, so those are my asymptotes. 13 pi over 12 is negative 1. 14 pi over 12 is negative 2. And 15, whoops, I put my asymptote on the wrong line here. Let's just fix that real quick. Sorry about that. So this is my asymptote. All right, because then 15 is negative 3. Okay, and there we have a cotangent. Okay, one more thing to look at, writing the function, very similar to what we did yesterday. Okay, tangent is what we're looking for. Okay, so it's going to be f of theta equals, okay, and we're going to write our function. So, period, using pi over 2, the formula for period here is pi over b. Well, very easy for me to tell. I could solve this if I wanted to. Alright, but b has to be 2. Okay. Vertical dilation of 3. That's your a value. Okay, vertical shift is down 3, making it a negative. And then our phase. Okay, so phase is c over b, which is supposed to be equal, in this case, to 3 pi over 4. Well, I have a b value. Okay, and I'm going to cross multiply here in order to solve. Okay, so c, I get 3 pi over 2. Alright, so setting all of this back up, we have plus or minus 3. Tangent of 2 theta minus 3 pi over 2 minus 3. And that's our function.